Zoom the recording. Okay, we're back. Hopefully this will work. Heck, what's it doing now? All right. Okay, I'm going to pause the recording again. Okay. Okay, there we go. I'm sorry. I'm not sure what that was about. And if we map all of this, we see that there is a network of rivers and lakes that used to flow through what is now very harsh desert just 10,000 years ago. That sounds like an incredibly long time, but it's well within the lifespan of our own species. As I've mentioned, the earliest Native Americans to come into this area would have seen these rivers and lakes and lived in a much cooler and moister world than is present now. I will have a lot more to say about climate change at the very end of this course. I know that's a topic that's on everyone's mind, but climate change does happen for natural reasons. Humans didn't cause this. There's other things that they do cause, but in time, we'll get into that. Anyway, there's a very few places in the middle of the desert where there's enough groundwater coming out of springs to feed these little ponds that preserve the last remnants of the life that used to live in that system of lakes and rivers. And they include some of my favorite critters on this planet, desert pupfish, little, I guess you might say minnow-like little fish in the genus Cyprinodon, not found anywhere else in the world. So if you were to drive out about an hour out of the town of Pahrump, which rhymes with dump, and visit Ash Meadows National Wildlife Refuge, you'd encounter a place called King's Spring, and there's kind of a wide shot of it. It's basically just a big pool filled with water that is soaking up out of the ground. And it's fresh water, it's warm water. It would be lovely to swim in, but you're not supposed to. They do have a pond where you can swim, but not here, because this is habitat for a fish called the Amargosa pupfish, Cyprinodon nevadensis, which you can see up there. And this fish is only found in the springs at Ash Meadows and a few others in the surrounding territory. It's not found anywhere else in the world. Not 5 miles away, you come to a place called Devil's Hole. It's basically a crack in the rocks. Down there at the bottom of it, it's maybe 6 feet wide. It's filled with water at the bottom. That water is rising up through a whole system of water-filled caverns. They've actually had scuba divers go down there to see where the caverns lead, and several of them died, which is why you're not allowed to do that anymore. And found in this crack in the ground that's maybe 6 feet wide by, I don't know, 20 feet long, in the water at the bottom, is Cyprinodon diabolus, the Devil's Hole pupfish. And this is the only place in the world you'll find it. The entire world population of Cyprinodon diabolus lives in a volume that's smaller than the room I'm sitting in right now. You could probably carry the entire species out in a couple of buckets if you had to. That's how rare this thing is, and it's found nowhere else in the world. Drive about 100 miles into Death Valley National Park, pick up your maps at the Furnace Creek Visitor Center, and keep going a ways and then pull off at a place called Salt Creek. You can walk this boardwalk along a creek that rises from springs in the hottest part of Death Valley. And in this place, the water's saltier than the ocean. The water's coming out of the ground very salty, whereas in the first two places that we've seen, the water's very fresh. And there's actually fish in here, and you can see them from the boardwalk. They're called Cyprinodon salinus, the Salt Creek pupfish. And I mean, they're still fish, okay, but they're different from nevadensis. For one thing, they can tolerate much more salt. For another thing, shapes of things like teeth are different because they're feeding on a different food supply, because there's different food available in a freshwater pond compared to a salt stream. They're different in color. They're different in behavior. I mean, they're still similar enough that we put them in the same genus, but they are a different species. And somebody did test this back in the 40s. If you try to put these together with nevadensis, they don't interbreed. And then finally, leave Death Valley and drive over the Panamint Mountains and take Highway 395 north for a couple of hours, and you end up in this really cool mountain town called Bishop. Great place for a base if you want to go hiking or mountain climbing. There's great skiing about an hour farther north at a place called Mammoth Lakes. I'm just saying. But you can also drive north out of town on some back roads, and you'll come to this patch of very, it's actually a little patch of wetlands in the middle of the high desert called Fish Slough. And in Fish Slough, you will find Cyprinodon radiosus, yet a fourth species of desert pupfish. This is called the Owens Valley pupfish. And sure, it's still a fish, but it is different from the other three. And the last time anybody tried this, back in the 1940s, you could not interbreed radiosus with any of the other three species that I showed you. They're just not compatible. Put mommy radiosus and daddy nevadensis together, and you just don't get any offspring. All right, so each species, whoops, I'm sorry, somebody has clicked on admit. There. Okay, each one of these species is restricted to isolated pockets of water, little spring-fed ponds and pools. They're separated from each other by many miles of desert. There simply is no way that pupfish could swim from Amargosa to Salt Creek or Salt Creek to Owens Valley. There's just no water there at all, ever. So you might be asking yourself, how did they get there? How did the ancestors of today's Salt Creek pupfish get there? The answer is that remember that all of these areas used to be connected by that system of lakes and rivers. So 10,000 years ago, there may have been only one species of pupfish. But as the climate started getting hotter and drier, there's less and less rain and warmer temperatures. What happens is that the rivers that connect all of these areas begin to dry up. And the lakes where the pupfish and other living things live get smaller and smaller. And what we have now is basically 4 little puddles. That's all that's left of that system of lakes and rivers. Surviving pupfish ended up in these 4 puddles, and each one has been subjected to natural selection. You know, some pupfish had to deal with the water getting saltier and saltier and saltier, or warmer and warmer and warmer in some cases. The Devil's Hole water comes out at about 35 Celsius. That's about body temperature. Each one of these little pockets of pupfish had to deal with, changes in their food supply, changes in, things like current flow, things like that, changes in the kinds of predators that might try to eat them. All of these things affected each one of these isolated pupfish populations separately from all the others. Now that they're separate, they no longer change in the same ways. They're no longer changing together. And so each one of these isolated pockets of pupfish has become a separate species in a few thousand years. And the story repeats itself elsewhere in the country because there's about 20 pupfish species in all in the Western United States. And most of them, it's the same story. They're restricted to just a few springs or streams or other little, we call them refugia, little pockets of suitable habitat surrounded by many miles of desert. And they're all where they are because their ancestors were one species, but different populations of that ancestral species have gotten cut off from each other by the drying up of the rivers that used to connect them. And now each one of those little pockets where the pupfish has survived, the pupfish have become unique to that pocket and different from all other pupfish. And so we have about 20 pupfish species in the American West and in Mexico. Most of them very highly restricted, most of them endangered. So that's the story. Ancestral pupfish spread through that system of rivers and lakes. They probably came in up the Colorado River. The pupfish populations become isolated as the rivers and lakes begin to shrink and those populations get cut off. Natural selection acts independently on each isolated population. Wash, rinse, and repeat, new species. There we go. And if it was only the pupfish, that would be cool enough. But the same pattern has affected other desert organisms like these minnows called dace. Here we've got 3 separate species of dace minnow that are found nowhere in the world but these pockets of water in the middle of desert. It has affected snails. There's a species of snail in a very alkaline spring in Death Valley called Badwater that survives nowhere else in the world but there. It's affected the plants. You get that pattern with lots of different groups of living things. And we can apply that to looking at things like the Galapagos finches as well. Remember, the Galapagos are this little group of islands off the coast of South America, and there's 14 species of finch that are not found anywhere else in the world. What must have happened is some South American finches must have crossed the ocean to reach the Galapagos. Now, finches don't usually fly 600 miles at a stretch, so maybe they got blown there by a storm or something. We may never know exactly how it happened, but they got there. They could no longer, there's a population of finches that's stuck in the Galapagos. They can't go back. They're in a different type of habitat in the Galapagos than they were on the South American mainland. There's different food, different predators, different temperature, different amounts of water, different everything. And so those finches begin to change by natural selection. And it keeps happening as finch populations colonize different islands of the Galapagos. Each one of those finch populations on different islands begins adapting to different conditions. Given some time, you end up with 14 new species of finch that didn't exist before. There's tons of variations on this story. lots of different examples I could have given, lots of different wrinkles as to how this works out in practice. But this may begin to give you an idea of how we can infer that new species do form, and how we can start reconstructing the relationships of all the world's species, the way they're related to each other through common ancestry. We can reconstruct what we call the tree of life. Now, I can't really tell this from talking at a screen, but when I teach this class in person, every time I mention the name Darwin or the word evolution, there's always a couple of people that start giving me side eye, because there are some religious groups that have decided that their beliefs are not compatible with Darwin or evolution or things like that. It's not my job to tell you what you're supposed to believe. That's not the way science works. We don't deal in personal belief. I'm not going to make altar calls to Charles Darwin or anything like that. We're not going to start singing hymns. I'm not going to make you singing, "Our Darwin is an awesome Darwin," or anything like that. That's just, no, we don't do that. And that's not what the state's paying me to do. What I want you to do is follow the logic. You can ultimately decide that this is all a bunch of hooey. That's up to you. But what you need to know is how we think about it. Like, what is the lines of evidence that we have to draw on? How do we put the pieces together to build this picture? You are free to believe that the pupfish were dropped there by aliens if you want to. Some of those populations are, by desert standards, not that far from Area 51. So, whatever, dude. You can, come up with any idea that you'd like. What you need to do is understand how scientists have fit together the lines of evidence that we have, how we're building a case here. If you want to decide they're wrong, that's your business, but you're not excused from learning how this works, from learning how it is that scientists come up with this stuff. Okay, maybe it's a sign from God, but it looks like my screen is frozen again. Oh, okay, how'd that work? Okay, guess it started again. Okay. So when we look at these pupfish, we hypothesize, because that's what we do in science, and we test the hypotheses, because that's also what we do in science, that the pupfish are all there in the places that they are because they evolved from a common ancestor. Diagrams that show you our hypotheses of common ancestry have a name. They're called cladograms. And this is one of them. All of these names that you see in italics are different species of desert pupfish. And whenever you have two branches that branch from a common point, that's just a way of representing the hypothesis that those descended from a common ancestor. So for example, don't worry, by the way, about the little numbers that you're seeing. That has to do with some statistical tests that we use to test these hypotheses that we don't need to get into for our purposes here. So anyway, you should see the Amargosa pupfish. There's actually several populations of those. And the Devil's Hole pupfish, which happens to live right next to it, we hypothesized that all of those descended from a common ancestor, and that a little farther back in time, that Amargosa pupfish and Devil's Hole pupfish descended from a common ancestor that they shared with Cyprinodon salinus. This is like a family tree. Oh, okay, I'm gonna pick on somebody. We've got somebody in this class whose last name is Moix, M-O-I-X. Moix is a kind of unusual name. I never met anybody named Moix until I came here, but we've actually got a fair number of Moixes in Conway, Arkansas. If you were to look in a phone book, if any of you remember what those are, last I checked, you would find maybe, I don't know, 10, 15 Moixes living in Conway. Why does Conway have, 10 or 15 Moixes living in this area? There's explanations you could come up with. The simplest is that some guy named Mr. Moix moved here, presumably back in the 1870s when Conway was founded and first settled. And
Stephen Morgan.
What's that? Oh yeah, it's the same with the Zeben Morgans and the Ham Beacons and the Frey Aldenhovens.
Yeah, Frey Aldenhoven. Yep.
And
that's the craziest thing.
Yeah, and the Otts. Yeah, we've got a number of the Maltbias. We've got a number of names in this area that are kind of unusual. And the simplest explanation for how they got here is that somebody named Mr. Moix and some dude named Mr. Zeben Morgan and somebody named Mr. Frey Aldenhoven settled down in Conway, probably in the late 19th century, and liked what they saw and stayed and had kids, and their kids have kids. So the simplest explanation for why we have so many Moixes in this town is that they're all descended from a common ancestor. By the way, if you were to ever visit a little town outside Winston-Salem, North Carolina, called Walkerton, you might notice that there's an awful lot of Wagoners in the phone book. That's where my family is originally from. I've never lived there, but that's where my great-grandfather and his family came from. So you could make the same kind of argument there. The reason there's so many Wagoners in Walkertown, North Carolina, is common ancestry. And the descendants of whoever that common ancestor was have inherited that last name. And I am frozen again, and I don't know why this is happening, and I don't like it at all. And I am ready for it to be over, because this is getting on my nerves. Okay, my face cam is working, but the screen is frozen. Oh, nerds. Why are you doing this to me? Part of the problem is I can't see my mouse. Okay, I'm going to pause recording again. Maybe.